Today we will learn to build a Streamlit app which retrieves the latest large language model related archive papers, or you can enter a URL of your own and you can just click any one of them and it will fetch the content and generate the summary text, a really quick summary, TLDR, and then it will actually generate an audio of it as well. Now we can play the audio. So every time you refresh this app, it actually retrieves the latest 10 papers from archive. You can actually find the URLs there and go to the actual papers if you like. So this is the latest paper from archive on large language models. Alternatively, you can actually copy and paste the URL of your own choosing and then paste it in this URL and click the generate podcast button. And then it will retrieve all necessary information, create the summary, and then create the audio, just like this. So this way you can always stay on top of the latest papers that are published on archive. This app is actually currently deployed at Railway. You can visit it at this URL, llm.tldr.app.railway.app. But I'll put the link in the description if you like to visit it. All the code files for this app, both the version that runs on terminal and the Streamlit app, will be available at my Patreon. Link will be in the description. The same app, before we start reviewing the code, actually runs from the terminal just as well. As you can see, when you run it, it retrieves the 10 latest large language model related archive papers. You can also paste your URL directly right here. Let's go ahead and say 9, and it will fetch the content from the URL. It'll actually apply moderation to it, get the text, and then play the audio. So let's begin by the more basic, the terminal example. First thing is that I wanted this application to work with only archive URLs. So here we have a function which is going to take in a URL and actually check it against the two main archive URL patterns. So archive papers have a main page, which looks like this, which starts with ABS and the number of the paper. And then when you click on download PDF, it takes you to this URL. I wanted this application to work with both. So meaning if you wanted to enter a custom URL, you can either enter this PDF URL or the main page URL for the particular paper that you want to deal with. That's why we have this function, which just checks it against the regex pattern, make sure that it's an archive URL. Then we have another function, which is going to check if it's the main page for the paper, and it's going to convert it to the PDF version, because that's where we are actually going to grab the actual text from. So this function does that by performing a check and a conversion. And then we have another function, fetch latest archive papers, which is going to automatically check for large language models and return 10 results. We are using archives library here. It's going to return the title and it's going to return the URLs, replacing the ABS with the PDF versions. And to extract the contents of this URL, I created a content extractor class. It's in this .py file. You can go there by clicking on this file or by control clicking on the class itself. So this file uses the request module Beautiful Soup by PDF and bytes.io to actually get text from HTML or from PDF. So this class actually will handle both regular URLs and the PDF URLs, but I am just really using it to get archive content due to the checks that I'm performing here. But this class will actually work for getting the content from either a regular URL or a PDF URL. And it just pretty much returns the result and also saves it to a file. That's about it. So this is like a utility file that we're going to use. That's the content extractor. If you're enjoying my content, please consider becoming a patron. While becoming a patron, you will gain access to over 200 exclusive project files, which has taken me by now over 2,500 hours, including the time I spent this year. I usually spend anywhere from 30 to 60 hours every week coding to put out 8 to 15 projects for my patrons. Also for these YouTube videos, so your support is much appreciated. And in this project, we are again using the GPT calls class I have created. If you want to know more about this, please watch my video on it, OpenAI Unified API. The link will be in the description. But essentially, it's just a bunch of utility functions to make all the necessary calls to OpenAI, including using JSON mode or streaming, or also includes the async versions of the calls, just to keep our life easier. So we are importing that. I'll talk about the methods that we are using. And we initialize our extractor, which is going to extract the contents from the PDF, and we initialize our GPT as the GPT calls class. We do set the max words per message to 50. This is a soft instruction. We actually take a look at the class. This message is appended to every message, if it's user, to softly instruct GPT to return that many words or less. This is a better approach than max tokens since your responses may get cut off. We will be using GPT 3.5 Turbo 0125. So to begin with, we actually fetch the papers by using the fetch latest archive papers function. So now we have the papers and now we print them on the terminal, as we have seen. Let me demonstrate again. So when you run it, we will fetch all the 10 papers, latest 10 papers on large language models and print them for user to select. And then we ask users to make a choice or enter their own archive paper URL. And then here we check if it's a digit and if it's a URL. If it's a digit, we pick that URL, which represents that paper that the user has chosen. Otherwise, we get the URL and then we convert to PDF URL function, right? Make sure that we can get the PDF contents of that. And if after we do the valid archive URL check, if that fails, we just have a print statement. And then we print, fetching the content from the URL, and then we use the extractors that get main text, which is going to do all the necessary calls within this function to get the text from PDF and join it and return it. After we have the text, since we're going to make a call to GPT 3.5 for the 16,000 context limit, I actually just decided to limit this text to the first 60,000 characters, assuming that should be less than the 16K token limit. But sometimes some papers actually still surpass that. Maybe something like 35,000 is more appropriate. I believe I did that change in the Streamlit version. Yes, in the Streamlit version, I'm using 35,000. So this can definitely be done better, especially if you're using GPT-4. Maybe you don't have to actually limit this at all. But for our purposes, this will suit us. And then we are now using a moderation endpoint to check if OpenAI finds the content inappropriate or not. Obviously, these are scientific papers and this is unnecessary, but I just want to demonstrate how in a user-facing app, which is going to be online, you want to perform moderation check. And I have included the moderate content check in the GPT call class in OpenAI Unified, which is essentially just the OpenAI call to the moderations endpoint with some text. And this endpoint is very fast and it's free, and it will return some result. You get the result like this, and its output.flag is whether going to be true or false. So if it's true, that means OpenAI flagged it, so you don't want to use that. So therefore, here we get the flag point by using the moderate content of the OpenAI Unified. And if flagged, we just print that text was flagged as inappropriate. Just consider this for your user-facing applications, which is something you would like to do if you're taking user input. And then we are just going to add a system message to our GPT. The add message function just simply adds with the role and the content a message to the message history. And history is just an empty list, which you have to populate normally manually. But this method automatically takes care of it for us. So the role is going to be system, and the message is instruction is going to be, your task is to summarize the given text in a calm and simple and informative podcast manner. So I wanted to take this project towards more podcast-oriented form, but then I just decided to go with simple summaries. I might actually do a video on that. Let me know if you'd be interested. Anyway, so this is supposed to just explain everything in a simple way, easily understandable. Don't spend any time with an introduction because it was always doing a, hey, welcome to our podcast style introduction. And if you wanted to use this app on a regular basis, I thought that would get annoying. I just wanted to jump directly to the main points. And I said, always end with visit echohive.live for more awesome apps like this one, because that's my website where you can find all my videos. It's echohive.live. While you're there, make sure to check the auto streamer as well, which auto creates contents. You can create live streams with it. You can actually watch a live stream where I display its abilities. It's autostreamer.live. Okay, so these are the instructions, and then we add another message, this time a user message, and we simply say with an if string, here's the text I want you to summarize, and we give that text. Remember, the text is the document, the text part of the PDF for the paper. And then we say generating the podcast, and gpt.getResponse will just simply make the call with that history, which we have populated with the add message method. That's it. This get response by default will actually do streaming responses to the terminal. And then after we get the response, the summary, that is, we just save it to podcast.txt. That's just for information purposes, really. And then we print getting the podcast ready to play, and we call the text-to-speech method of the GPT, which is simply the regular text-to-speech call to the client.audio.speech endpoint with a model, voice, and text. And then we simply have a path, and then we're going to stream that to that file, which is going to be speech.mp3. And then to play the audio, we're going to use Pygame. I believe I do want to say that for text-to-speech to work, you may have to install FFmpeg. If you do a quick search for how to install FFmpeg, there's this tutorial. I'm not sure if you're going to need this, but if you do, just take a look at this. Just do a search on Google. This FFmpeg might be the one that you need to install to use text-to-speech. Anyway, this is just going to save our speech to the speech.mp3 file, and then we initialize our Pygame. We load the audio file, and we play it, and we have to run a while loop while the mixer is busy playing. So this accomplishes that. So now if we come back here and select, let's say number 3, and we fetch the contents from the URL, and then we generate the podcast. As you can see, even with 35,000, if we run this again, remember in the beginning it was 60,000, but we reduced to 35,000. Now we shouldn't run into that error. Let's test it. Let's run 3 again. Yeah. See, this time it worked. This is the summary. It's very fast, and then we are generating the audio. Yeah, there we go. You can easily find all my projects at my website, echohive.live. And if you're a patron, you can find the code download links here as well. While you're there, make sure to check out the Auto Streamer, which is an app I created, which auto-creates content, allows you to record it or live stream it, and it builds a course website in real time. You can watch the live stream I did, showcasing its abilities. You can also see the sample website it has built. This is the website we had built during that live stream.
NumPy introduction and arrays.
You can also use this website to brush up on your Python. I also created this fastpython.up.railway.app, which is deployed at Railway, which allows you to quickly check out some Python concepts. It's a pretty cool app. It's available at this URL. I'll put it in the description. Okay, so now let's take a look at the Streamlit app. Again, much of the functions are going to remain the same. We are still using content extractor, which is going to get the contents from a URL or PDF, in our case, only PDF files. We are using Streamlit, of course. You do need to pip install it. The requirements are here, and it will be available at Patreon as well, along with the code files. And we are, again, using GPT calls. The isValid archive URL remains the same to perform a check to make sure the URL is a valid archive path. Convert the main archive URL, if given one, to the PDF version, and then fetch the latest papers. And then we initialize our extractor in GPT. And then we create some columns. You can actually create columns. You don't even have to have separators. But if you do, you just give them each values. And this is to display these 3 links at the top. These are my personal links. This one goes to AutoStreamer. Do check it out, autostreamer.live. This one goes to my website, echohive.live, where you can find all my videos. And the last one is for the code download link for this project at Patreon, for example. So this is how we can create these. Let's go back to the code. So we create these columns, and we say with column 1, we use SD's Markdown, and we are actually going to insert some HTML. And this is just regular HTML. And here's the link, and here is the title to that link. And we do say unsafe allow HTML through. And the same with column 2 and 3. Now, the spacers, normally speaking, Streamlit should position these evenly separated, but in my case, it wasn't working out, so I just put spacers. So just keep that in mind. And this next up is the SD.title. This is what is displaying right here, the title of the page. Next up is the sidebar. You can create that with sd.sidebar title about this app and sd.sidebar.write with some text. And this displays this text explaining what this app is about. You can actually close this or reopen it. And then again, we use the fetch latest archive papers function to get the papers. As you can remember, we were using the archive library to fetch the latest 10 results, searching for large language models. And then we check if there are papers. Then we create 5 columns. And then we iterate over all the papers. And then we actually truncate the title. So as you can see, that's why they are truncated. Because the titles are pretty long and it wouldn't fit neatly. And then we create colons, just like we have done up here, except we do it here programmatically. We create a button, and then we input the necessary information. And we do store in the session state to trigger processing. And with the expander, we show the URL. Okay, and so therefore, if you wanted to clicking on the button will retrieve that and summarize that paper, but this expander actually will link to that paper. So that's what we are achieving here. So what we're doing is when this button is clicked, we are putting to the Streamlit session state, which is kind of like a semi-temporary, semi-perpetual, or just temporary, but it's a place to store variables, and we are storing the selected paper there. Okay. And then, because therefore we are going to see if that has been selected, because if we have something there, then we can actually start processing it. Because we can process this 2 ways, right? One way is by clicking the buttons and getting the summaries of the top latest 10, or by inputting a URL. So we are separating, in a way, the functionality of these 2 buttons. That's why we are inputting whichever of these papers into the selected paper category, and we're checking for that. As you can see, selected papers at first none, and then we assign an ID to it, and we add it to the session state. And we also can take in a URL here. Okay, that is that input box we have seen. And then we check if there is a selected paper, or if selected paper is in session state, and session state is the selected paper, or if the generate podcast button is selected, then we generate a URL string. If there is a selected paper, then that is the URL. If there's a selected paper in session state, then there's the URL. Maybe I've done some redundancy here. Anyway, but we know that this works. Otherwise, then the URL is the URL input, which we take from the user. And we check if that URL is valid, and then we print an error message if it's not. Otherwise, we convert it to a PDF URL so we can get the contents. And if all that is true, we start a spinner saying, fetching content from the URL, and we extract the content. And we just simply print a number of words. That's just information, really, nothing necessary about this. And we truncate the text due to the context length limitations. There's probably so many better ways to do this, but this is the way I implemented it. Feel free to improve upon it. And then with the spinner saying, checking for inappropriate content, we get the moderation output, make sure that OpenAI moderation doesn't flag it. And now with sd.spinner generating the podcast, we add the system message and then the user message along with the text of the paper. And we get a response from the GPT. And then we display the podcast text as a subheader, and then we just simply write it to the web page. And that accomplishes that. And then with sd.spinner saying getting the podcast ready to play, we create some temporary file. And then we call text-to-speech, as we have done in the terminal version, which is a call to OpenAI's text-to-speech service. And then using sd.audio, we simply just put an audio box, as we have done here. Now, this is online and it's working fine, but I've tested this on my iPhone, and this little audio widget comes up with an error. I'm not sure if that's the case for every user. I don't know, maybe iPhone doesn't like Streamlit's audio element. If you don't know the answer, please do let me know in the comments or at Discord. I'll try to come up with a solution. Maybe I'll convert this to a fast API app as well. Do let me know if you'd like to see a full stack solution to this. But this is how we can build something like this. And I'll show you next how we can deploy that Railway. Normally speaking, when you build a Streamlit app, you deploy it at Streamlit's cloud, as I have done with some of my apps, including the GPT-4 Autocoder. As you can see, GPT-4 Autocoder is deployed at Streamlit. Its URL is .streamlit.app. But I wanted to deploy it at Railway because Railway actually gives you some statistics about it. So you can actually see it being used for some kind of, at least by looking at the network traffic. Whereas that is not so much available with Streamlit. That's why. So next up, I'll show you how to do that. So Railway, Railway is very simple, and once you get used to it, it's extremely simple. As you can see, I have many apps deployed on Railway, and usually speaking, you will go to, you will get a Railway account. You link your GitHub to it, because Railway will deploy your projects from GitHub. So each one of these are actually deployed from GitHub. So in my dashboard, I go to new project and search for Streamlit. However, the search wasn't working. I'm not sure if I'm doing something wrong. So instead, I actually went to railway.app templates. And here you can search for Streamlit apps. So these are some templates you can start with. There was the Streamlit Hello app, okay, which I've selected, and I said deploy now, and I'll show you what it looks like. I'm going to select it as a private repository and test Streamlit. Let's say test Streamlit. So if I do this, it's going to create a repository with this template. Yeah, I have to. There's no spaces allowed. Let's go ahead and do that, and it will not only create that repository, but also will create the entire project and deploy it with a live URL, a temporary URL, which you can change. You can also assign custom URLs. So now if I go to my GitHub, I can do a search, test Streamlit has been created. And this is the app that we have just deployed. So essentially the main app is the hello.py and has pages and stuff. So this is not really what we want, but it gives us what we want. So we can modify this. Okay, that's how I've done it. You don't have to, and I'll show you how you can do it from scratch as well. So we don't need pages, right? And once this is stopped deploying, I'll show you what that looks like. What you need is, in our case, we have a main_st.py file, while we have content extractor.py, which this main file uses, and we have OpenAI Unify. So we need these three files. And we, of course, need requirements. So Railway can install these requirements on the machine in the cloud. So that's really what we need, okay? We need the main files, and then we need the requirements. And we also need a way to tell Railway how to start this app. And this is something I neglected to mention here. To start a Streamlit app locally, after you have Streamlit pip installed, you would say Streamlit run main_st.py. So this will run the Streamlit app on your computer, right? And I can click on localhost, and it will actually start it. So this is the app. So what we're going to do is, what we want to do is we want to tell Railway, well, here is our files, right? Which is going to exist on GitHub. And we also want to tell it how to run it. And this railway.json does tell it to do that. Say Streamlit run hello.py. Now, one other thing is that, when you run it locally, it creates a local host, and 8501 is the port. When you're running it on Railway, the address should be 0000, and the server.port should point to this $port. So these are the important parts of it, okay? So this is the part we want to modify. Alternatively, you can change it here as well. So this app is now deployed. This is the Hello World app. It has a plotting demo here, which is pretty cool, mapping demo, and a data frame demo. So these are the pages that present here. So Streamlit is a very cool app. So this is the app we just deployed. It's online. It's at this address. But we want to change it. We want our code to work with it. I just want to, before I move away from this, maybe I'm going all over the place, but I hope this is useful information for you. The command to run the app, you can find or enter it at the settings as well. So if you go to settings and scroll down, there is this deploy and custom start command. As you can see, it says here, this comes from deploy.start command in railway.json. And this is the exact same command, which we found in our deployed repository here. So this may sound complicated, but it's really not. So what you need in this GitHub repository is the files necessary to run the app, which are the exact same that you need to run it locally, plus a file called railway.json in this schema to tell Railway which command to run. That's it. If you know how to write this, or if you have a copy of it, you don't need to do all that template stuff that I did myself. Okay, so now that we have this, I'm going to go ahead and delete these pages because we don't need them. I'm going to delete that whole directory, commit those changes. Every time you make a change on this GitHub repository, you will realize that that Streamlit app will redeploy. But we have to make some more changes. For example, we don't need this utils. We can delete that. Delete. We need to upload our own requirements, so I can just simply edit this file with my own requirements. Just going to copy all this and paste it here. Okay, commit these. Hello.py, I can modify it with the contents of my main _st, or I could delete that and upload mine. I'll just show you how I've done it previously. So main _st.py file contains the main Streamlit app, so I just copied it. I'm going to get back here and override this, just like that. And I'm also going to change its name to, let's say, main.py. I'm going to commit. Okay, so we also need those two files. I'm going to go back to the main repository, and there's test.streamlit. I'm going to click on add file and upload files. And now from my folder, I need the content extractor and OpenAI Unified. I can also upload requirements just to show you that it will overwrite. Once these are uploaded, I commit. So we have done all these. See, now we have our requirements.txt, our main.py, and we have the content extractor and GPT calls as well, which is our OpenAI Unified. I hope this was clear that we're just going to transform this template into our Streamlit app pretty much. And next up is we need to change this command because we no longer have hello.py. It needs to say main. And this has a lot of other commands, but these you don't need these. You can keep them if you like, but I'm just going to keep it simple. So this is going to be our run command, streamlit.main, with this address and with the port that Railway specifies. So when we do all of this, our app is going to be building. Now, one last thing. You need your OpenAI API key, and you can add it as an environment variable here. You go to your variables. So this is what it looks like, right? I click on this, and here in variables, I would click on new variable, and I would create OpenAI API key, and your value here, and click add. And the application, since it detects it from the environment variables, will be able to read that. I'm not going to do this because I've done it already in the example that I've shown in this one, and we've seen that it works. We don't need the API key for app to start, I believe. So let's just wait for this app to build. And then while this is building, you can see all the changes that has taken place. You can go to view logs and you can see your build logs. And after deployment, you can see this deploy logs is kind of like your terminal where you can see all the information. Again, just to reiterate the point, if you go to your settings and if you scroll down, you can change the address from where this app is running. You can also link it to your custom domain. But more importantly, if you didn't have the railway.json, I believe you can actually change this. But it's auto-detecting right now, this command. Okay, so our app is deployed. And here is its URL. We can click on it. Since it's just got deployed, it may give you issues. You may have to wait for like 30 seconds, but let's go see our logs to see if there's anything wrong. As you can see, we have no error messages in the terminal, and it's running through this. So we just need to wait a second. Oh, here we go. And now it's deployed. You can change the URL as I've shown you. Now this won't work because we didn't put our OpenAI key, but as you can see, it was working here. You can see it running again. Let's select time series diffusion. It's fetching the content, generating the summary. There we go. And then getting the audio. And this is pretty quick because we are dealing with short lengths. There we go.
In this research paper, empirical evaluate GoHive.live for more awesome apps like this one.
I hope you enjoyed this. Do let me know what you think, and I'll see you in the next video. You can easily find all my projects at my website, GoHive.live. And if you're a patron, you can find the code download links here as well. While you're there, make sure to check out the Auto Streamer, which is an app I created, which auto creates content, allows you to record it or live stream it. and it builds a course website in real time. You can watch the live stream I did showcasing its abilities. You can also see the sample website it has built. This is the website we had built during that live stream.
NumPy introduction and arrays.
You can also use this website to brush up on your Python. I also created this fastpython.up.railway.app, which is deployed at Railway, which allows you to quickly check out some Python concepts. It's a pretty cool app. It's available at this URL. I'll put it in the description.